When you wake up and look out at the world, everything you see starts with a single source of energy. It usually begins with something that creates its own light, like the sun. The sun produces light, but most things around us don't. The grass, the red dirt, a wooden desk, these only become visible because light bounces off them and travels into our eyes. It's easy to imagine that our eyes shoot out invisible beams to look at things, but it's actually the other way around. Our eyes act like catcher's mitts, simply waiting to catch the bouncing light rays from the world around us. Once that light is on the move, it follows one very strict rule. It refuses to bend. Light always travels in perfectly straight lines. We can see this in action as rays travel through the void of space toward Earth. There are no curves and no detours. Every single ray points exactly straight ahead. Because light stubbornly stays on this straight path, it can't cheat. It can't go around corners. This means that whenever light hits an obstacle, it reacts in a way we can see and predict every single time. Think about standing under a huge mango tree on a hot afternoon. The tree is a solid object that light cannot pass through. Because those straight light rays can't curve around the branches, they leave a cooler, dark region right behind the tree. Look closely at how light is blocked. There's a sharp, dark center, the umbra, and a fuzzy outer edge, the penumbra. Scaling this up, when the moon passes between Earth and the sun, it casts a massive version of this same shadow onto Earth. This is what that looks like from the ground. The dark disk of the moon is physically standing in the way of the light, proving that even over millions of miles, light continues to travel in a straight line. We are seeing darkness form because light rays simply cannot reach that spot. It's a gap in the light, shaped perfectly by the object that got in the way. But what happens when light hits a surface that is perfectly flat and shiny? Instead of being blocked, those straight rays bounce off and head in a new direction. You can see this clearly on the calm waters of Lake Bunyoni. The surface acts as a natural mirror, bouncing the light from the hills and sky back into our eyes with incredible detail. To understand this bounce, imagine a normal line at a 90-degree angle to the surface. When an incoming ray hits that spot, it bounces away at the exact same angle. Because this bounce is perfectly consistent, it creates a perfect copy of the source. When you look into a mirror, this precise bounce creates a virtual image. The light is reflecting off the glass, but it looks to our eyes as if there's a whole world sitting just behind the mirror. That reflection stands upright and stays the same size. It even appears to be the exact same distance behind. The only catch is that everything is flipped sideways. This left-to-right swap is why the word ambulance is often painted backward on the front of the vehicle. When a driver looks in their mirror, the flip happens again, making the letters readable. The mirror bounces those straight lines into our eyes so precisely that our brain builds a perfect flipped copy of the world. Once we understand these strict rules of blocking and bouncing, we can start to manipulate light to build our own tools. We can build a pinhole camera using a simple dark box. By poking one tiny hole in the front, we block almost all the light, allowing only a few specific rays to pass through to the back. Because these rays travel in straight lines, they have to cross over each other to fit through the hole. The light from the top of the tree hits the bottom of the wall, and the light from the bottom hits the top. This creates an image that is real, but perfectly upside down. We can also use mirrors to see around obstacles, using a tool called a periscope. By placing two mirrors at 45-degree angles inside a tube, we can catch light from above a wall, bounce it straight down the tube, and then bounce it again right into our eyes. This exact setup allows sailors to stay safely underwater while using mirrors to see exactly what is happening on the surface. From the shade of a mango tree to the high-tech sights of a submarine, the visual universe makes sense because light follows the simple, unbreakable geometry of a straight line.